In the following minutes, we are going to present an innovative approach for vertical and horizontal integration of simulation models. Our motivation to develop this approach was driven by the need to connect a complex simulation on semiconductor supply chain level with detailed microsimulations on fab or line level. It is today still a challenge to integrate detailed line models of a whole supply chain into one single monolithic simulation model. This causes immense computational effort. Additionally, running this model by one simulation engine consumes too many resources in terms of storage and CPU time. Our efforts resulted in the idea to link a simulation model on the macro level, indicated in the upper part of the screen, the simulations on the micro level as depicted in the lower part. Let's focus on one node of our macro simulation node chain and take a closer look at the micro simulation, which in this case is performed by the simulation software engine Analogic. Microsimulations, as this example of a semiconductor backend line demonstrates, consists of every single part of line equipment connecting conveyors and transport units, such as the trays in this case. A simulation model of a complete supply chain within the semiconductor industry typically includes literally dozens or even hundreds of nodes, each of which represents a fab or a section of those production lines. The approach of the vertical model integration is to begin on the macro level, represented again in a simplified form in the upper part of the screen, and to implement a software that allows the user to connect a macro level node with a micro simulation of a specific production line. So the macro level initiates the micro simulation, either automatically whenever necessary, or in this case, for demonstration purposes, it is done manually. The software that connects the macro simulation engine with the micro simulation is a tool called SimController, a connectivity system passepartout that has been extended substantially in the productive 4.0 project. It handles data transfer, synchronization, and the transfer of results between the models. Each node of a macro simulation model may be connected to a micro simulation node. Additionally, micro simulations can be performed by different simulation packages from various vendors. For instance, it is possible to focus on a micro model implemented by means of PlantSimulation from Siemens, or as previously demonstrated, the node could be created using Analogic. It is also possible to interconnect two or more independent micro models based on PlantSimulation or Analogic. Furthermore, it is also possible to integrate the micro simulations horizontally simply by defining entities passing from one model to the next one. This solution is not just limited to PlantSimulation or Analogic models. They can be combined in almost any fashion to any process topology. The cycle of synchronization between the models is not predetermined and depends on the slowest micromodel, which determines the speed of progress of the combined model execution. This part of the video demonstrates an integration of three horizontally integrated micromodels. We can observe a PlantSimulation micromodel followed by a micromodel implemented in Analogic, and the chain is completed by another PlantSimulation model. The macro supply chain simulation demonstrator started, which in turn initiates the underlying microsimulations. Here you can see the entities that are created in the first software tool through the horizontal tool chain. They move from PlantSimulation to Analogic and finally back to PlantSimulation. The different colors are used to demonstrate that each entity is being carried over from one micro model to the next one. If the supply of material in one model is interrupted, downstream models are also affected. Thank you very much for following this brief overview of the new possibilities of vertical and horizontal model integration resulting from our simulation developments within the scope of Productive 4.0.